Welcome to a tutorial on the 8085 address and data bus multiplexing and demultiplexing. Okay, so we know that the 8085 microprocessor is basically a 40-pin chip, okay? And in all these 40 pins, it contains, well, address pins, all right, data pins. Then it has few pins for controlling, peripheral devices and all. So all these, functions together are basically, well, controlled by the 40 pins present on the 8085 microprocessor. So here we're basically gonna, focus our attention on the address and the data pins concerned. Now we know that the 8085 microprocessor, well, has 16 address pins. Okay, it has, well, 16 address pins, and these 16 address pins are, well, together known or referred to as the 16-bit address bus. Okay, 16-bit address bus, because it just sends a 16-bit digital code, or rather 16-bit binary code, corresponding to the memory address, which is supposed to access from the externally connected memory chip. Okay, now the 16-bit lines, 16 address lines of the 8085 microprocessor, basically, they're just, well, split into two groups. Okay, two groups of 8 lines each. Okay, now here you can see the two groups and how they've been just split up. So this is entirely all the 16 lines, the address lines of the 8085 microprocessor. So we have them divided into two groups. So the upper half that you can see over here ranges from A8 to A15. So this is the higher 8. Okay, that just ranges from the A15 to it just ranges from A8 to that of A15. Okay, and there is the lower half of the lower 8, that is this particular group. Okay, that just ranges from, well, 80 to 87. Okay, now the upper half that you can see over here is referred to as the higher order address bus. Okay, while the lower half is just, well, referred to as the lower order address, okay, or data bus. Okay, now it's pretty interesting why it's referred to as an address and both as a data bus. It's because, well, whenever the microprocessor needs to communicate or rather exchange data, okay, to and from externally connected memory chips or other peripheral devices, it uses the lower order lines. Okay, it uses a lower order bus. Okay, and these being 8 in number, since the 8085 is basically an 8-bit processor, it also helps communicate along with other 8-bit devices, like, for example, memory, other peripheral devices, so on. So it's pretty interesting as how the 8085 uses the same lines, that's the lower order address data bus, both as an address bus as well as a data bus. That's what I'm going to show you over here. So let us just, well, assume that in this example, okay, I'm just going to give you an example here. Let's just assume that we have a memory address, or rather, let's say that we have an external memory chip. Right, so there it is. Now every memory chip, well, basically has certain number of lines in common. Well, it has, well, a certain number of address lines. So let's just, well, take it as a rough diagram as well, that this entire span of lines represents the address lines of the chip. So well, these just represent the address lines of memory chip. Okay, right, there we go. And now, apart from the address lines of the memory chip, okay, which are just used to access each of its addresses or each of its registers concerned, okay, it also has an enable pin. Okay, so this is the enable pin, EN bar. Okay, or rather, I may write it a little more clearly over here, EN bar. Okay, and now you can see that this particular pin is basically an active low pin, which means that in order to use this memory chip, we need to enable it, and in order to enable it, we need to supply a logic 0 signal over here at this enable pin. Okay, so what we do is that we just take it and ground this thing, okay, so that we can get a logic 0 voltage level over here, and now the memory chip is enabled. And apart from that, we have two other pins also. It is referred to as the read and the write pins. Okay, so here they are. Okay, so this is going to be the read bar, okay, and the write bar pins. Generally, these pins are also in some memory chips they are active low, in some they're active high. It depends upon the chip you're using. So I just assume that they're active low in this case. And apart from that, it has a data bus. Okay, so it would have this data bus. Okay, so the data bus needs to be an 8-bit data bus, otherwise the memory chip won't be able to communicate the data to the 8085 microprocessor. Alright, now let's just shift this thing to the right. Alright, so there you go. We just modified the diagram a little bit. Okay, and now we're going to need the microprocessor here. There you go. So now here I'm just going to give you an idea of how things basically take place. So let's say the 8085 needs to access a data present at, let's say, the memory location 2F03H. Okay, so let's say this particular memory location of this memory chip, that's the external memory chip over here, contains a certain data that the 8085 microprocessor requires. So what it needs to do is that the microprocessor, the 8085, needs to read, okay, it needs to read or access the data from this corresponding memory location of the externally connected memory chip. So first it needs to send an address, okay, this particular memory address whose data it wants to access. So it's gonna send the memory address right over here, okay, through its 16-bit address bus. Okay, so it just sends the 16-bit memory address. We're gonna just write that down over here. Okay, and the address is of course 2F03H. Okay, and it wants to access the data present at this particular memory address. And whenever it just sends this particular address to the external memory chip, the chip realizes that it has to output the data present in this memory location, and correspondingly the 8085 also has the read and write pins through which it just controls whether it is supposed to read the data from the memory chip or write the data. Writing means also storage, or write the data into the chip. Okay, so the read and the write pins are just connected somewhat this way. Alright, so there I connect the read pin, and also the write pin needs to be connected to the write pin. Now whenever there is a logic 0 signal on the read pin, since it's an active low input on the memory chip, so on receiving this logic 0 signal level on the read bar pin of the external memory chip, and also the 16-bit address, okay, on its address lines, the memory chip realizes that it has to, the 8085 microprocessor wants to read the data present in its 2F03H address register, okay, and thereby it just outputs the entire thing. Okay, I'm just going to use a different color in this case. So it is just going to output this entire data, okay, through the 8-bit data bus, and it is going to send it to the 8085 microprocessor. Alright, okay, so don't mind my drawing a bit. Alright, so it just sends the data into the 8085 through the data line. So here it just sends the 8-bit data into the 8085. So now you can basically get the idea of how the process basically takes place. Whenever the 8085 needs to communicate with an external memory chip. Now there are other processes involved, okay, within this operation of reading a data from an external memory chip. So this was basically a rough idea of what is happening around here. Now I'm gonna give you the accurate state of affairs in this, involved in this particular process. Okay, but one thing I'd like to tell you over here, that this was just basically an idea. Okay, and previously I just told you all that the 8085 communicates data through its lower order address bus. So here, when it's just transferring the 16-bit memory address, immediately what happens is that its lower order address bus is basically multiplexed in order to receive data. Okay, now this 8-bit data that enters into the 8085 goes through the lower order data bus. Okay, so this just goes through the lower order data bus. Okay, just gonna write that down over here so that you don't confuse this thing. Now I cannot include all the details in this diagram, of course, so that's why I'm gonna make a new diagram over here which just includes all the real affairs involved. Okay, so here we are. Now this is once again a diagram of the 8085 microprocessor. Now I haven't talked about another very important pin that we have over here. Okay, I'm gonna talk about the ALE pin. Okay, ALE pin. So here the pin ALE basically stands for address latch enable. Okay, that's what the term ALE basically means. And this particular pin is basically used to control a latch chip. Okay, we use a 74LS373 latch chip, all right, in order to multiplex and demultiplex the lower order address and data bus. Okay, so here it is. Okay, so in this latch chip, what basically happens is that the latch chip controls, it has basically an enable pin, also referred to as G. Okay, and it requires a logic 1 signal in order to be enabled. Okay, and also there is an output control pin, which is basically an active low pin, and it needs to be grounded always for the chip to function properly. Now what happens is that here the ALE pin of the 8085 is connected to the enable pin of the latch chip, and whenever the ALE would output a logic 1 signal, only then the chip would be enabled, and during this state the chip is basically transparent, meaning whatever just falls on its input pins, that is the pins on the left over here, you can see the same written. Okay, the same would appear on its output pins. Okay, so now the latch chip basically consists of latching elements, which are nothing but D flip-flops. Okay, level triggered D flip-flops, and they're used to latch the data. Okay, once the data is latched, the ALE signal goes low, okay, or becomes a logic 0 voltage level, and at that moment this chip doesn't remain transparent anymore, and hence any change in inputs is, the chip is basically rendered insensitive to changes in its inputs, and it just latches the data on its output lines. So that way we can just use this chip in order to multiplex and demultiplex the bus lines. Okay, so let's just join the lower address bus, okay, to the latch chip concerned. So I'm just going to join the lines over here. So there you go. Okay, and this way all the lines need to be connected. So you can see that in this latch chip, there are 8 latching elements. Okay, and that's why we have 8 inputs and their corresponding outputs. So there it is. We've just joined the lines, and similarly we extend the lines of the higher address bus also. Okay, so now let's just take this example over here. Let's just hope that the microprocessor wants to communicate to a memory chip externally connected, and will access data from this memory address, that is 2F03H. So what would happen is that, let's just split it up. 2F03H corresponds to a binary code of 0010, okay, all ones and then all zeros, and then well, 00, 11. So this entire code would appear on its entire address line. So there are certain steps in how this entire thing basically happens. So first of all, this 16-bit code, so this is basically a 16-bit code or 16-bit memory address. Now this code first appears on its address lines. All right, there. Now you can see that for the higher order address bus, the data is already well communicated to the peripheral device concerned, if it's a memory chip in this case. Now till the moment this latch is enabled, okay, the change in the input, okay, that's the data available on the lower order address bus, doesn't come out of the other end. Okay, it doesn't appear at the output of the latch chip. So what happens over here is that the ALE pin is well sent to a logic 1 voltage signal. Okay, it's just given a logic 1 voltage level, and at that moment the latch is enabled, and this particular data okay, available on the lower order address bus appears on the output of the latch chip also. There you go. So at this moment what happens is that we just say that the lower order address or data bus has been multiplexed. Okay, so this is just referred to as, well, I'm sorry, well, this is just referred to as the demultiplexing of the lower order address bus. So we say that at this moment the lower order address bus has been demultiplexed. Okay, so this moment the demultiplexing of the lower order address bus will takes place. Now after some time, okay, a few clock cycles maybe, the ALE pin's voltage level goes low there, which means that the latch chip at this moment is disabled, and the data that was available as the input to the latch chip has been latched already. So the data from the lower order address bus lines has been latched, and well, it still appears at the output lines of the latch chip concerned. But wait, the data, the same data that was available on the lower order data bus is now no longer there, and at this moment this particular lower order address or data bus now is ready to function as the data bus. Now it is ready to accept data from the memory location concerned. So if you just think that, well, this 16-bit address is just well sent to some kind of well externally connected memory chip, then now the memory chip is supposed to supply the 8-bit data into the 8085 via the lower order address bus, which now well functions as the data bus. Now we say that at this moment what has happened is that the lower order address bus has been well multiplexed. Okay, it has now been well multiplexed to function as a data bus. Okay, now it's ready to accept data from the memory chip. So if you just send this 16-bit address to the memory chip, okay, and then you just enable the latch, and what happens is that the memory chip understands that the 8085 processor wants some data from the corresponding memory address, that is 2F03H as an example. Okay, so now the memory chip is going to send the data through this line. So this is where it is supposed to send the 8-bit data. So we need another parallel connection provision to the lower order address lines, of course, and at this moment the data is going to enter into the 8085 microprocessor through this green lines, okay, which just correspond to the external provision, okay, hardware provision of connecting the 8085's lower order address lines to the data bus of the external memory chip concerned. Okay, so there are certain steps involved in this thing. Okay, so we can just summarize it over here. So here's step 1. Okay, 16-bit memory address is first generated, and then we are gonna have the output on the ALE pin. Well, that's step number 2, of course. Well, what happens is that the ALE pin right over here, that's its output, goes to logic 1 state, Okay, and then this moves on to step number 3, of course, where the latch chip over here is enabled by the ALE pin's output signal, and it is rendered transparent. Okay, and now this again carries over to step number 4, where the 16-bit memory address appears at the output of the latch chip, and together is just sent to any external memory chip or any external peripheral device connected. Okay, now I would also like to add in this step number 4 that the transmission of the 16-bit memory address from the lower order address bus and into the output of the latch chip, well, this is basically referred to the condition where the lower order address bus, that is 80 to 87, is basically de-multiplexed. So this is basically referred to as de-multiplexing of the lower order address bus. Okay, so now step 4 just includes the same, that is the lower order address data bus is basically de-multiplexed. Okay, now this just leads us to step number 5, where the output on the ALE pin goes to logic 0 after transmission of the data to the output of the latch chip. And at this moment, the data at the output of the latch chip is basically latched, okay, and the data is held over there. And after this, we have the steps 6 and 7, following the step number 5, where the voltage level on the ALE pin goes to logic 0 over here. Okay, what happens is that the latch gets disabled, and finally the lower order address or data bus, that is 80 to 87, is right now multiplexed. Okay, and that's what we have over here. So this just gets multiplexed to work or function as the data bus. Okay, and now it can basically, the microprocessor can read any data from an external peripheral device or memory chip also. So this is the process of multiplexing and demultiplexing the lower order address data bus of the 8085 microprocessor. So with that, we just come to the end of this tutorial, and we're going to be catching up with y'all in the forthcoming ones as well. So till then, it's just going to be a short goodbye for now, and thanks for watching.